What's up guys, welcome back to the channel. Today in this video we'll be integrating the following polynomial that you see here. As you can see, this polynomial is one of the longest polynomial that we will be solving today. But before we start, you can pause this video and try to solve this problem, and let's see if your answer is going to be the same as the one at the end of this video. Now, before I start solving this one, guys, I would like to say thank you very much, guys, for watching, and not forgetting those who subscribe to the channel, those who commenting, and those who also like the videos. Thank you very much, guys. Do not forget to subscribe to this channel, and also don't forget to like this video as well. So let's start, guys. Let's do this problem here. So first of all, before we do any integration, let's look at the terms here. When I look at this problem here, there are certain terms that need to be simplified. So before you integrate, you need to simplify some of the terms. So the first term, the second term, and the second last term, they need to be simplified. We cannot integrate with the trigonometric ratios on the denominators. So how are we gonna do this simplification? Remember, guys, when you simplify, you don't get rid of the sigma and the dx. So we continue write the sigma like that, and then we continue simplifying. So let's start with the first term. We have 2 over sine x multiplied by tan. Now we need to use the inverses. So you need to remember what is the inverse of sine, what is the inverse of tan. So as 2 is going to be written like this, it's still fine. The inverse of sine, we know that is cosec x, and then the inverse of tan is cot x. Right, so we go to the next term as well. The next term, we also need to use the inverse in order for us to take this trigonometric ratio to the numerator. All right, so this is going to be 7, obviously, negative 7. Then what is the inverse of sine? It's going to be cosec squared x. There we go. Now the third term, there's nothing we can do. Everything is fine here. It's already simplified. So we just write it as it is. We have 4 multiplied by pi to the power of 3x. And then this term here, which is the fourth term, also is still fine. So we don't do anything here. We just write it as it is. We have 4 multiplied by e to the power of negative 4x. All this divided by 3. There we go. Now this term here, the second last term, it also similar to the first term. We have 2 trigonometric ratio on the denominator, so we need to take them to the numerator by using the inverses. So what is the inverse of cos? The inverse of cos is going to be sec x multiplied by the inverse of cot, which is going to be tan x, right, plus the last term. The last term, guys, it's fine as well. We don't have to do anything here. We just write it as it is. It's 7 pi over 8. Do not forget dx as well. Remember, dx basically means that we haven't yet integrated. So when it's like this, we can able to integrate. For some of you might be confused, where do I get this inverses? You need to go to the description. I've made a video explaining all these inverses here, the reciprocals. So I'm gonna leave those videos explaining the reciprocals on the description. Now it's time for you. It's time for us to integrate. So let's integrate, guys. Let's start with the first term here. As you can see, the first term. What do we have on the first term, guys? On the first term, we have the trigonometric integral. Now, when you look at this, we have cosec multiplied by cot. This, guys, it's actually the derivative of, if I still remember very well, is derivative of cosec. But then you have to be careful, guys. If this is positive, this is the derivative of negative cosec. So if I would write the integral here, remember the integral is supposed to be like this. So the integral of cosec x multiplied by cot x dx. When you find the let's do this let's do this when you find the let me go back, guys. When you find the integral of the following here, cosec x multiplied by cot, the integral is gonna be negative cosec x. Do not forget that one, guys, right? Divide by n. So our n here, which is 1, so you don't have to worry about it. So since our integral here for this one is going to be negative cosec, we need to write it there on the first term. So this is how we do it, guys. So it's going to be 2, which is our coefficient, multiplied by negative cosec x. We don't divide by any we don't divide by any coefficient of x, because the coefficient of x here is actually 1. So do not forget that one, guys. Very, very important. Now let's go to the second term. Now the second term, we have 7 cos x squared x. So how are you gonna integrate this one? Again, you need to know your differentiation, guys. The derivative of cosec squared is actually the derivative of cosec squared is actually the derivative of let me double check. It's actually the derivative of cot. Yes, cosec squared is actually the derivative of cot. So you need to remember that whenever we're integrating, we are doing the opposite of the derivative. So when we do the integral of cosec, let's take this is negative cosec squared x dx. Let me just put n here. The derivative here, guys, the integral here is gonna be positive cot n x divided by n plus c. Let's not forget that one, guys. These are very tricky. You need to know your derivative of the trigonometric ratios in order for you to solve this. If you don't know the derivative or the trigonometric ratios, you might not able to solve this one. So in order for you to solve this one, know the derivative. So let's write it here. Since this is positive negative, so our answer here is going to be positive 7. Then we're going to have positive cot x. So we divide it by 1 because the n here is 1. All right, so let's go back. Let's continue. Let's do the other term. But before we continue here, just in case you don't know the derivative that I'm talking about, there is a video on the description. Go and watch that video to understand this way much better than I'm trying to explain here. Right, let's go to this term. As you can see, this term here, guys, we have 4 pi to the power of 3x. So for the fact that x is the exponent, this basically means we're going to use the exponential integral. Now the formula for that, usually it's like this. It's gonna be a to the power of nx. Okay, let's not forget k, which is a coefficient, and then when we derive this, it's gonna be y is equaling to k. Now don't forget, guys, we do have k as a coefficient. We're just gonna write it as it is, k, then a, then n x, but this is gonna be over n, the coefficient of x, natural log, then the base, which is a in this case, plus c. Do not forget that this is a indefinite integral, so we have to use this. So let's do it, guys. Let's do it. So as you can see, our k here is 4. You're just gonna write 4 here, and then you're gonna write our base, which is pi. You're gonna write our exponent, which is 3x. Then from there we divide. Now when you look at the formula, we divide by n multiplied by natural log, then the base. So our n here, which is 3, natural log, then we have our base, which is pi. Right, so this is basically how you do this one. Again, guys, if it so happen that you don't remember or you want to know more about this integral or this law, There is a video on the description. Go and watch that video and the description there. Right, let's go and do this one as well. This one, as you can see, still this one is the exponent integral. We have 4 as a k or coefficient. We have e as a base, and we have -4 as a coefficient of x, and x as an exponent. Now we have divided by 3. So as you can see here, since x is our exponent, this is a exponential integral. So when you do this one, again similar to that one we did previously, we're gonna multiply by 4. We're just gonna write this as it is there. Then from there we divide by the n. So what is our n? In this case now our n is -4. Then multiply by natural log, then our base here, which is e. But let's not forget we also have 3 here, so multiply by 3. So this is basically the integral of this term here. Now this second last integral, this is similar to what we did here. If it happened that you didn't understand the first one here, let's try to do this one. Hopefully you will be able to understand this one. This one here, we have sec x multiplied by tan x. As you can see, these are actually the differentiation of sec. So remember, when we integrate, we are basically going backwards. So what is the integral of sec tan x? So if you look at your differentiation of sec, you're gonna have this. So basically this is gonna be just sec x. Again, if it so happen, guys, that you don't understand where this is coming from, go and check the video on the derivatives of trigonometric ratios. Right, so from here we come to this one here, the last one. There is no x here. Since we are integrating, we are going backwards with differentiation. So basically what you should do here is just multiply by x, or you can use the power rule. The power rule is still fine here, as you can see here. So you just write this 7 multiplied by pi divided by 8, then multiply by x, then plus c. Remember, when you integrate, don't forget plus c. I know, guys, this is a bit long, but it's very, very important for you guys to able to identify each term and what rule are you going to use for each term. So now it's time for us to write the final answer, simplify where we need to. So here we just multiply by this 2. It's going to be -2 cosec x, and this one is fine. There's nothing we can do here. It's just 7, then we have cot x. And this one here also, there's nothing we can do here. It's a plus 4 pi to the power of 3x over 3 natural log then pi. There we go. This one here, there's simplification that we need to do here. First of all, negative and negative, this is going to become positive, and then we have 4 divided by 4, it's 1. So in the numerator we're left with e to the power of -4x divide by, now let's look at this. We have natural log e. Natural log e, guys, it's always 1. If you put this on the calculator, you'll get 1. Multiply by 3, and then we're left with 3. Then plus sec. There's nothing we can do here. Sec x is fine. And then we come to the last term, which is gonna be 7 pi x over 8 plus c. So this is basically how your answer is supposed to look like. I know it looks a bit complex and bit difficult, but to be honest, guys, it wasn't really that difficult as long as you know the rules and able to identify where to use the rules. When it comes to the trigonometric integrals, you need to pay attention to your differentiation for trigonometric ratios in order for you to solve this type here. I hope you guys managed to understand. If it so happened that you didn't understand what happened here, you can rewatch the video, you can leave a comment, and also you can try to watch other videos where I do these problems here. But anyway, thank you very much, guys, for watching. Do not forget to subscribe, and also do not forget to share this video with your friends. Till next time, guys, cheers.